In this video, I'm going to show you how to use the part pattern operation and the volume mesh pattern operation, which recently came out in version 13.04 and 13.06 of STAR-CCM Plus. I take as an example a compressor case where we have a single blade sector for the impeller and the diffuser, and we want to generate the full 360 degrees geometry to simulate in STAR-CCM Plus, for example, in an unsteady case. You can see that now there are the periodic contacts defined at both sides of the sector that we have, and you will see that we will need this to correctly execute our pattern operation. So let's define the pattern operations that we need. We go to Operations, New, Surface Preparation, Circular Pattern, select the diffuser part as input, and define the number of copies that we want to have of this part. Then we generate the same operation for the impeller part and define a different number of copies to be made, as there are less sectors in this case. In a general situation, you will need to check the coordinate system and the axis direction around which the circular pattern operation is copying the geometries. But in this case, it's already correct. So we can execute the operation. Now the operation is completed. We can see that we have the full 360 degrees geometry for a compressor. The darker gray area is the one that is currently assigned to regions, and we will need to assign the rest later on. If we go to contacts now, we can see that the original periodic contact is propagated with the pattern operation, so that we can have interfaces among the rest of the copies. We have to point out as well that the contact between the impeller and diffuser copies, in this case, is not propagated, as the two geometry parts are patterned in two different operations. So this is something that we may have to check when defining the full interfaces. Now we can update the regions. So I'm going to select all the diffuser copies we have created and add them to the already defined diffuser region. I'm going to repeat the operation for the impeller copies as well. After that, we can define the volume mesh pattern operation. So we go to Operations, right-click, New Mesh, Volume Mesh Pattern Operation. We select it, and as input, we can select all the copies which the pattern operation have generated. Then we execute the operation. Now the operation is completed. We can see that we have generated a fairly heavy mesh in a small fraction of the time that it would have taken if we generated the full mesh in a single operation. Let's go and check the result of the mesh a little bit closer. So we can see that at the interfaces between the copies of the impeller, for example, the mesh is perfectly conformal. As a last step, we need to make sure the interfaces are correctly defined among the different bodies. We can see that thanks to the naming convention, the interface is correctly propagated among the different parts. We simply need to change their type. So what was a periodic interface is now an in-place interface, and the same goes for the mixing plane interface between the impeller and the diffuser part, which becomes another in-place interface. At this point, we are ready to launch our simulation. Thanks for watching the video, and I hope you will find it useful.